Hello everyone. Today we'll be solving problem number 22, generate parenthesis, right? You can just go through the question and understand the question with the help at, with the help of the example. So I'll just summarize the question for you so that it will be easy to understand. So we are tasked with generating all the possible combinations of well-formed parenthesis. While I say this one, just try to understand this one. We are tasked with generating all the possible combinations of well-formed parenthesis for a given number n, right? Each well-formed combination must satisfy the condition that at no point does the number of closing parentheses should exceed the number of opening parentheses. So the number of opening parentheses and the closing parenthesis has to be equal. They shouldn't exceed, right? This is the main this one specification they have given. This is one of the main requirements. So and initially what we'll do, let's discuss the approach and let's see all the edge cases and then write the code with this one, the code, and then discuss the complexity. So before, let's see the example as well. So here n equals 3 they have given. Here they have mentioned all the possible combinations. You can clearly see here. So here you can count one more thing. The specification they had given was the opening this one parenthesis. How many opening parentheses are there? Same amount of closing parentheses should be present. So it shouldn't exceed, right? Closing parenthesis should not exceed the number of this one opening parenthesis. So here you can clearly see we have 3 closing parentheses and we have 3 opening parentheses. Same goes with this one as well, right? Same goes with all the this one parenthesis here, all the combinations of parentheses here. So n equals 1 they have given here in the second example. Only one opening parenthesis will be present. So only one. This is the only one combination of parenthesis that is present. That's what they have given in the output, right? So let's discuss the approach for this and then let's move on with the edge cases. Let's see the edge cases one by one and finally discuss the finally write the code and discuss the complexities. So I'll just go with the approach initially. So let me give here, just give me a second here. What happened to this one? Yeah, let me go with approach here. So here the first thing is just keep in mind we are going with the iterative backtracking with stack. The approach that we are going with here is stack with iterative backtracking, right? So this is the approach that we are going with. Let's go with the approach step by step. So here let's go with the initialization part. We will be making use of the stack to track the current state of the string. So we'll be making use of the stack to track the current state of the string, right? When I say current state of the string, we'll be going with the number of open parentheses used and the number of closed parentheses that is being used. For that, we'll be making use of the stack opening parentheses and the closing parentheses, right? The number of opening parentheses and the number of closing parentheses. So the second step here is, first one was initialization. Second step is, let's go with the core idea or the logic. So adding an opening parenthesis here, this one, adding an opening parenthesis, we have to add an opening parenthesis if the count of open parenthesis is less than n, right? We have to add the opening parenthesis if the count is less than n. We are adding the closing parenthesis if the count of closed parenthesis is less than this one, count of opening parenthesis, right? This we have to keep in mind. If count of closed parenthesis, I'll just take this one, parenthesis is less than count of opening parenthesis. So we are adding the opening parenthesis if count of opening parenthesis is less than n, right? And we are adding closed parenthesis if count of closing parenthesis is less than count of opening parenthesis. This one we have to keep in mind. This is very important step. This itself is the logic. We are making use of the stack to track the current state. Nothing but the number of open parentheses used and the number of closed parentheses used here. That is the reason we'll be making use of the stack. Here, this step is very important. We have to add an opening parenthesis if the count of opening parenthesis is less than n, and we are adding an closing parenthesis if the count of closed parenthesis is less than the count of opening parenthesis. That's what we saw, right? Finally, let's come to the third step, or the termination. So when the length of the string becomes this becomes 2 into n. This, just remember this one. When the length of the string becomes 2 into n, what does the 2 into n indicates? Basically, it indicates all the n pairs are being used, right? This one indicates all n pairs are being used, right? So then we will add it to the resulting array. So while I say termination, when the length of the string becomes 2 into n, then we will add it to the result array. This is fine. Finally, let's move on to the fourth step, nothing but the iterative traversal. We'll not be making use of the recursion here. We'll be making use of the stack for this one. Tracking. We'll be making use of the stack for the state tracking, right? So we'll be making use of the stack for state tracking instead of the recursion to implement the backtracking iteratively. So to backtracking iteratively. One more thing, avoid recursion as much as possible. Go for this one, iterative thing rather than the recursion. Recursion takes up a lot of memory, right, rather than the iteration. So it's better to go with the iteration rather than the recursion. So here the final step is we'll be going with the this one, stack for the this one, state tracking instead of the recursion to implement the backtracking iteratively, right? I hope the approach is completely clear. Next, we'll be going with the edge cases step by step and then write the code and this one. Explain the complexities, right? So here, let's go with the edge cases one by one. Let me give here edge cases. The first edge case that we are going with here is smallest input. Nothing but I'll just take the input n equals 1. The output that we can consider here is this one. We have already seen this one in the example, right? This will be the output. This is for the smallest input. And let's go with the second edge case, nothing but n equals 2. And what will be the combination here? This can be this one, either this one, right? This is for the input, larger input, right? This is the second edge case. And let's move on with the third edge case. I'll just come here. Let's go with the third edge case. Nothing but I'll just consider input n equals 3. So n equals 3, we must include all this one, right? Just give me a second here. We must include all the combinations. The same thing in the example that we are considering here. So this one will be, output will be here. Either this one, this one, this one, third one, this one, and finally this one, right? These are the 5 combinations. So this is for n equals 3. This is for the max open at start here. This one I'll give max open at start, right? Let's move on with the fourth edge case. Nothing but this is for balanced midway. Let me give here balanced midway. While I say balanced midway, let me consider input here n equals 3 itself, the previous one. This must include basically this one. The output will be this one. This must include the balancing open and closed midway. Here you can clearly see this one, right? This must include balancing open and closed midway, right? So we have considered 4 edge cases. One is for the smallest input, one is for the largest input, one is for max open at start, one is for the balanced midway. I hope all the edge cases are clear. Next, let's write the code, and I'll explain the code while writing the code itself and discuss the complexity of the code. So as we are discussing the approach, let's initialize the result array to store all the valid combination. I'll just give here result. So next step is we are making use of the stack here, right? So let's go with the stack to store the current state of the string and the counts of open and close. I'll write it in this way. You can clearly understand. And this one string, let me initialize this one to with the empty string. Open, let me set this with 0, and also close, let me set this one with the 0. This is fine. What we have done here, we are making use of the stack to store the current state of the string and the counts of open and close. And the third main step here is, or the second step here is, while there are states left to process, then we'll continue, right? So I'll just give here while length of the stack here. So then we will extract the current state from the stack. So how can we extract the current state? I'll just make use of the flower bracket here. Let's go with str open close. Extracting means we'll be making use of the pop, right? We have to remove. I'll just give here stack pop. Pop is a function. So this is fine. The next step is, if the string has reached the required length, that is nothing but 2 into n. We had discussed this one in the approach, right? If the string reaches the required length 2 into n, then we will add it to the result array. Then we will skip further processing for this state. Then if it has reached the required length, nothing but 2 into n, we have to add it to the result array. So for this, I'll just consider simple if condition. If length of the string equals 2 into n, then what we will do, we have to add it to the result array, nothing but we have considered res. And let's push the string here, str we have, right? So this is one thing. Finally, we have to skip further processing for this state, because we have already got the length 2 into n, right? So I'll just come out of this one. Next step is, we have to add an opening parenthesis if open count is less than n, and we have to add the closing parenthesis if close count is less than open count. We have seen this one in the approach as well. Again, I'm telling, we have to add an opening parenthesis if opening count is less than n, and we are adding an closing parenthesis if close count is less than open count. This is simple, right? I'll just make use of the simple if condition here. If open less than n, then what we will do, for adding, I'll just make use of the push here. Let me add here. This has to be str, right? Will I give stack str plus opening parenthesis over here. Let me give here open plus 1. Let me give here close. This is fine. This is fair. Let me copy the same thing and make the necessary changes. First one was for first if condition, whatever I have written in the line number 13. Sorry, why this got open? Yeah, in the line number 13, this is for we are adding an opening parenthesis if open count is less than n. Next one here, we are adding a closing parenthesis if close count is less than open count. I have to consider here close less than open, right? When closing parenthesis is less than opening parenthesis. Here this will be same stack dot push str. Instead of the opening parenthesis, we are going with the closing parenthesis here. Open here, this will be just open here, right? This will be open and close will be close plus 1 here. Instead of open plus 1, this will be close plus 1 here. I hope this is completely clear. The final step is we have to return the resulting array, right? Containing all the valid combinations. We have to display all the combinations in the output. That is the reason we'll be returning the resulting array. So I'll just give here return result. So let me format this one once. So why this is getting open? Yeah, let me hit the run. So yeah, here you can clearly see all the sample test cases are getting passed. So let me hit the submit button now. So you can clearly see this works absolutely correct. So the solution works absolutely correct. All the test cases are getting passed, right? So the code works absolutely fine or correct. So let's discuss the time complexity and the space complexity very quickly. Here the overall time complexity would be big O of 4 to the power of n by square root of n. So I'll just give here overall time complexity. This one, the approach that we went with here is stack with iterative backtracking right here. So the overall time complexity would be here big O of 4. What did I give here? 4 to the power of n by square root of n, and the overall, what will be the overall space complexity here? The overall space complexity would be big O of n here, right? So yeah, for now this is it. Thanks for watching, guys.